Hello, this is Dominic Boats, and I'm doing the second part to the general chemistry exam. So, the question is, what is the mass of mercury 2 bromide? And then, what is the percent composition of each element? If mercury 2 bromide is 91.16 grams in total, how much of each element is present? So, first we find out the total mass of mercury 2 bromide. So there is, in total, there are 3 atoms. There is 1 mercury atom, and 2 bromine atoms. Going and referring to the P table, if we look up the atomic mass for mercury, we find out it is, might take me a while, hopefully not, but it might. Mercury. Mercury. It's almost there. It's on the tip of my tongue. It's a matter of where is it? Mercury. Dang it, my iPad's gonna die. I need to turn down the brightness. Just search it up. Too more confusing. Oh, mercury. And that's Hg. So Hg, and that is 1 mercury is equal to 200.59. Yep, 200.59. That is that. And then bromine. Let's hope that we can find this faster. Bromine is right there. It's also highlighted. So 1 bromine atom is equal to 79.904 U's. Okay, so now since we know that there's 2 bromine atoms, then that means that there would be the quantity 79.904. That would be 2 of them. So you would take 79.904, multiply that by 2. So that's to cover the 2 bromine atoms. And then for this, there's only 1 of the mercury present. So that would just go down here. 59. And you'd add that, and that would give you a total. Pulling out the calculator. I don't know if any of this will register on the screen, but so you got 200.59 plus, I'm just going to type it all in one, use parentheses, 79.904, and you get a total of 360, and you got to make sure to go to the right amount of significant figures. The biggest amount of significant figures present is 5 significant figures. And so my total answer would be 360.398, but that's 6 significant figures. So that means you'd stop at this one. So you would have 360.39. And that is the total for mercury 2 bromide. Okay, now what's percent composition? So again, going back to here, we know that there are 3 atoms in total present within mercury 2 bromide. So that means that this total mass can be broken up into 3 different parts. And yeah, so we know that let me just think about this, because they're not all 3 equal parts. We know that that's bigger. Okay, well, and we can just take what that equals, okay, so 200.59, which is the total mass for one mercury atom, divided by 360.39, and I'm going to use the total mass in this case because I don't have to do a significant figure to the same thing. 200.59 by 360.398. That gets me a weird, decimal. And that gets me a 5.5565791153, which gets rounded up to put into the nearest percent. Well, still using the same significant figures, so I go 5.657%. Okay. So that means this makes up about 50% of that. Yep. Okay, so that's percent composition for the mercury atom present. Now for the 2 bromide. So what I'm going to do is I'm going to find out what the total for the 2 bromide atoms, the total mass of that would be. So in that case, I'm just taking this separate part. Take 79.904 times 2. That gets me 159.808. Divided by, again, the total molecular mass. And that would get me to that. And if I take that number divided by the 360.398, gets me again a weird silly decimal, but that's okay. So it gets me 0.4434208847. We can get rounded to the nearest percent, but still to the 5 significant figures. It's 44.342%. And just to check myself, I can take those percents, which is 55.657 plus 44.342, and that should equal about very close to 100. And that's only not 100 because we had to round to the nearest significant figure, so we're good there. So that means that the 55.657 is the percent composition for the 1 mercury atom present, and the 44.342% is the percent composition for the 2 bromine atoms present. Okay, now answering the next part of the question. If the mercury 2 bromide is in total 91.16 grams, how much uh, how much how much of each element is present? So you just take, in this case, you can just take, so let's just start out with the mercury. So the mercury, again, is 55.65%. And that just means in general it'd always be the percent for the whole entire, like, I don't know, compound. So what you can do is you can take the percent, then multiply it by the total amount of your compound, which is 91.16 in this case. So 91.16 times, and again, you don't multiply by the percent, but by the decimal form of it. So 0.556657. If you multiply that, it should give you the percent. Multiply that out times 0.55657, and that gives me this, which is 50 point, and still rounding to the five significant figures in this case, because you're using the percent, which is the highest amount of significant figures. So that gives me 70.736. I apologize for the background noise. I'm trying to do this in my dorm, but people are always loud. So that is the total percent. How much of each? So that is the percent of the element, and wait, not the percent. That is 50.736. That's the amount of grams that are present of the mercury atoms. 736 grams of mercury. Okay. Now next, moving on to the bromide. So again, doing the same that we did for mercury, do 91.16. It's the total amount of grams for a composition in this case, or the compound in this case, and then multiply it by our previous percent that we got of bromide, which is the 44.342. But since you're multiplying, you gotta change your percent to a decimal. So take 0.44342, and you multiply that. And when you multiply it, you get 91.16 times 0.44342. You get 40.42, and then again to the fifth significant figure, you get 40.422. So that means 40.422 grams of bromine are present. And to double check, you should get pretty darn close to that. So you take this and add it up with this, and we'll get us close to that total. So just for fun, 50.736 plus 40.422, add that up, again gets us very close. We are off by 0.002, which is very close, and the only reason, again, is because we had to round to the nearest fifth significant figure. So yeah, I hope I answered it right. And yeah, that's my video submission. Thank you.